Okay, in one of my earlier videos, I talked about, or I promised I should say, to show you guys how to find the square root of 42. So that's what this video is going to be. And it turns out that 42 is halfway between two perfect squares, 36 and 49. So let's find out how to find the halfway point between the two perfect squares. We're going to do that first. Very simple. So what is the halfway point between 36 and 49? Step one, we just subtract 36 from 49. We get 13. Right, remember, quickly, just a quick review, a perfect square is, well, when you take the square root of the number, you get a natural number. So in other words, what do I mean by that? Square root of 36 would be 6, right? It's a natural number. It's not a fraction, okay? It's not fractional. 6 times 6 equals 36. Okay, and of course, 7 times 7 equals 49, right? So that's step one. You subtract the smaller of the two perfect squares from the larger. In this case, we get 13. Now in step two, we always subtract 1 from the result we get in the first step. Okay, so 13 minus 1, and then we divide by 2. So in this case, 13 minus 1 is 12, divided by 2 is 6, pretty straightforward math, right? And as it turns out, this result that we get in step 2 will always be an even number. Always. Whenever you're looking for the halfway point between two perfect squares, this number will always be even. Okay? And as it turns out, the distance between two perfect squares will always be odd. Yeah, that's pretty cool, right? The distance between two perfect squares is odd, but the halfway point is always going to be even. Okay? The third step, very simple. We take the lower of the two perfect squares, in this case 36, and we add the result we got from step 2. Right? So 36 plus 6, 42. So that's our halfway, that's how we determine our halfway point between two perfect squares. In this case, 42 is a halfway point between 49 and 36. Now some of you may be saying, you know, why do you subtract 1 and all this stuff? That's just a method that I came up with that works really well, okay? That's the short answer. Now, this is an algebraic equation that I have already shown in another video, okay? It's important to understand to review this algebraic equation for square root. Okay, this is a method I came up with, this expression. Okay. So I suggest you review that video first. Okay, and that video, just go to YouTube, right? YouTube.com. Right? Type in the search box. My channel is called Get Us Realist. Okay. And you'll notice some things come up in the search. Anyway, whatever comes up in the search, I have quite a few videos. Look for this one here called Square Root of Imperfect Squares. That's the one you want, this one right down here. Okay? Review that, or I should say view that. It's about an 8-minute video, a little longer. Review that, you'll have an understanding of how this expression came about and the history behind a little bit how I came up with this, okay? So, you'll notice in this algebraic expression there are variables, and I talked about in the other video, but the number we're looking for, 42, is r is equal to 42 in this case, and we're going to equal to 6. That's pretty clear where the 6 came from, right? 6 times 6 is 36. D, 13, that's pretty obvious, right? We got that from up here. Okay, I'm going to skip over F for a second, come back to it. And S equals 6, that's also pretty obvious. Okay. In this case, we see 6 twice 6 times 6 is 36. We also see it in step 2, but just for future reference, this is always going to be the square root of the lower of the two perfect squares, right? So that's where that number came from. It has nothing to do with step 2. The 6 came from step 1. It is the square root of 36, the perfect square, right? 6 times 6 is 36. Got it, guys? All right. So that's where that came from. Now, where does 4 come from? Because all these other numbers, they're easily derived, right? 42 is the number we're talking about. We're trying to get the square root from. Okay, it's called a radicand. Okay, the n equals 6. That's pretty obvious where that came from, right? Okay. N equals 6. Okay, again, go look at the video for that, because n is actually an iterative number. It's actually the 6th piece of the 13 pi. I won't get into all that right now, but look at the other video. 42 is 6 numbers above 36, right? So that's where that came from. Right, 36 plus 6 equals 42, so that's where 6 came from, in case you want to know. Right, 13 is obvious where that came from. We talked about that. 6 is obvious. Okay, but the 4, f equals 4, where does it come from? Okay, so this is really important to understand this part. Whenever we're trying to find the square root of a number that is halfway between two perfect squares, which is what we're doing here, obviously, f will always be 4. Always. Okay? And when I get to the end of this video, I'm going to give you guys a little assignment for those of you that are interested, okay? And I'm going to ask you to find the halfway point between two other perfect squares, okay? And f will equal 4, because just like I said, whenever you're dealing with a halfway point between two perfect squares, f is always going to be equal to 4, all right? All right, so now that we have all these variables, have their assigned numerical values, we can take that expression and simply just substitute the numbers, right? Square root of 42 is equal to 6n over 13d plus 1 over d times f, 13 times 4, right? Plus s, 6. The number we come up with is this number, without the little superscript 2, or what we call it, to the power of 2. Ignore that for a second. Just this number right here that's in blue. This is the number that we get as a result of this very simple mathematical equation, right? But when we do square it or multiply it by itself, we get 42.0003. So you can see how accurate this is. Very accurate, right? So the first 3 steps, just in a quick review, was finding the midway point between two perfect squares, right? And then we just took this algebraic expression, plugged in assigned the variables, numbers to variables here, okay, which are all derived, easily derived. And then we just simply do the math, and there it is, voila. Works really, really well, okay? So, what's next? Well, I encourage you to try this for yourself. Okay, for those of you who wish to leave a comment, and please, I'd like you to leave a comment, even if you don't get the answer right. Okay, this is obviously not a real math class, I should say, right? I mean, you're not being graded. Simply a YouTube video helping people out who are interested. Okay, but I encourage you to try this assignment. Okay, using the method that you see in this video that you just learned. Okay, I want you to find the halfway point between 16 and 25. Okay, same thing we just did up here. Just follow these 3 steps up here. Okay, find the halfway point between 16 and 25. You can pause the video. You can pause it right now if you want. Okay, use your calculator. I don't care. Get a piece of paper. Open up your notepad. Whatever you got to do in your little computer. Okay? Find the halfway point between 16 and 25. Very simple. Okay, some people do it in their heads. Okay, but whatever it takes, get the halfway point. Okay, then solve for square root of that number, whatever the halfway point is, between 16 and 25. Then I want you to solve the square root using the method you see in this video and another video that I mentioned. Okay. So you can see, I mean, I made good on my promise for those of you that watched this video, right? I told you how you're going to get the square root of 42, and there it is. It's very, very accurate. And if you try to solve for the square root for the halfway point between 16 and 25, using this method, you're going to find out it's also very, very accurate, because it always is. It will always be accurate. Okay, the next video I'm probably going to do, we're going to talk about how to find the square root for probably, I think last time in another video I mentioned, we talked about finding the square root for 37 and 38. I don't know if I talked about finding the square root for numbers 47 and 48, which, as you can see, is at the end of this entire range, right? If we go from 36 to 49, right? Well, from 37 to 48 here, those are the numbers that are in between those two, right? So in the other video I talked about how to get the square root of 37 and 38. But this time we're going to talk about how to get the square root for numbers like 47 and 48. And really what you're going to, if you kind of go over this algebraic expression that I talked about, you know, what you're going to realize is that it really comes down to the variable f. Because this expression never changes. And the accuracy of this expression has a lot to do with f. Okay? So f is really what we call the key. Right? It's very pivotal to finding accurate results. Okay? Alright, that's it for now, guys.